Right, now we'll start with another chapter of integration called as substitution. So we'll start with integration, next type of integration, that is called as substitution. Let's see a sum with this. Integral of dx upon 1 plus 2x minus 5 the whole square. Now let's see this. Since we do not have a formula for this, what we will do is, you will say, let us assume that 2x minus 5 is equal to t. Differentiate with respect to x. If I differentiate with respect to x, I will get 2. d by dx of x is 1. d by dx of constant is 0, is dt by dx. Therefore, I can say that dx is dt upon 2. Once you get this, then I can say let's see the sum, dx upon 1 plus 2x minus 5 the whole square. Instead of dx, I can write dt upon 2, 1 plus 2x minus 5 we have assumed as t, so this will be t square. Constant comes out, integral of 1 upon 1 plus t square dt. Integral of 1 upon 1 plus t square is nothing but tan inverse of t. Resubstitute the value of t, so this will be tan inverse of 2x minus 5. Fine, let's move on to the next one, guys. Integral of a raised to 5 minus 4x dx. Right? Let us assume that 5 minus 4x is equal to t. Differentiate with respect to x. If I differentiate with respect to x, I will get d by dx of 5 is 0, d by dx of minus 4x is minus 4, is dt by dx. Therefore, I can say that dx is dt upon minus 4. Let's copy the sum, integral of a raised to 5 minus 4x dx. This can be written as integral of a raised to t, dx can be written as dt upon minus 4. Now, this can be written as minus 1 upon 4 integral of a raised to t, a raised to t dt, minus 1 upon 4 integral of a raised to t is nothing but a raised to t upon log a plus c. In the previous sum also plus c. Once you finish integration, you have to put plus c. Now, this can be written as minus 1 upon 4 a raised to t. Substitute, so a raised to 5 minus 4x upon log a plus c. So your answer is going to be 1 minus 1 upon 4 a raised to 5 minus 4x upon log a plus c. Right? Let's move on to the next exercise. Integral of x raised to m minus 1 cos x raised to m dx. Right? Let's see this. You will say let x raised to m be equal to t. Differentiate with respect to x. If I differentiate with respect to x, I will get d by dx of x raised to m is dt by dx. I will be using the formula d by dx of x raised to n. That will be mx raised to m minus 1 is dt by dx. Therefore, you can say that dx is nothing but dt upon mx raised to m minus 1. Let's start with the sum. I is equal to integral of x raised to m minus 1 cos x raised to m dx. Integral of x raised to m minus 1 cos x raised to m we have assumed as t. Dx is nothing but dt upon mx raised to m minus 1. X raised to m minus 1, x raised to m minus 1 cancels. So 1 upon m integral of cos t dt 1 upon m, integral of cos t is nothing but sin t plus c. We substitute the value, so this is sin t is nothing but x raised to m plus c. Right? Let's move on to the next sum, guys. Integral of sin root x upon root x dx. Right? Now, you will say that let root x be equal to t, differentiate with respect to x. If I differentiate with respect to x, dy dx of root x is 1 upon 2 root x is dt by dx. Therefore, you can say that dx is 2 root x dt. I can say I is integral of sin t upon root x. I substituted the value of root x there only. And instead of dx, I can write 2 root x dt. Root x gets cancelled. This is 2 integral of sin t dt. Integral of sin t is minus cos t plus c. We substitute the value of t, so minus 2 cos t. T can be written as root x plus c. Fine. Let's move on to the next one, guys. Integral of x square plus 2 upon x square plus 1 a raised to x plus tan inverse of x dx. Now we are very certain that you cannot have a formula with tan inverse in integration. So what we will do is, we will say let x plus tan inverse of x be equal to t, differentiate with respect to x. So dy dx of x is 1, dy dx of tan inverse of x is 1 upon 1 plus x square is dt by dx. Therefore 1 plus x square plus 1 upon 1 plus x square is dt by dx. I have taken LCM here. Therefore I can say that dx is 1 plus x square upon x square plus 2 dt. Let's start with the sum. I can say I is integral of x square plus 2 upon x square plus 1 a. This can be written as a raised to t. Dx can be written as x square plus 1 x square plus 2 dt. X square plus 2 x square plus 2 gone, x square plus 1 x square plus 1 gone, cancels, that is. So this will be a raised to t into dt with respect to t. So this will be a raised to t upon log a plus c. A raised to t, t is nothing but x plus tan inverse of x, x plus tan inverse of x upon log a plus c. Right? Let's move on to the next sum, guys. Integral of x raised to 4 5 plus 2x 5 the whole raised to 7 by 2 dx. Right? Let's see this. You will say let 5 plus 2x raised to 5 be equal to t, differentiate with respect to x. So 0 plus 2 dy dx of x raised to n, nx raised to n minus 1 is dt by dx. Therefore you will get 10x raised to 4 is dt by dx. Therefore you can say that dx is dt upon 10x raised to 4. Let's start with the sum. I can say I is integral of x raised to 4. 5 plus 2x the whole raised to 5 can be written as t. So that is t raised to 7 by 2. Dx can be written as dt upon 10x raised to 4. X raised to 4, x raised to 4 gets cancelled. 1 upon 10 is constant. Integral of t raised to 7 by 2 dt. integral of x raised to n is x raised to n plus 1 upon n plus 1 plus c. So 1 upon 10 t raised to 9 by 2 upon 9 by 2 plus c. This can be written as 2 ones are 2 5s are. So 1 upon 45 t can be substituted as 5 plus 2x raised to 5 the whole raised to 9 by 2 plus c. So that will be your final answer. Fine. Next, let's see the next one, guys. Integral of sec cube x tan x, sec cube x tan x dx. Let us assume that sec x is equal to t. Differentiate with respect to x. So you will get dy dx of sec x is nothing but sec x tan x is dt by dx. Therefore, you could say that dx is equal to dt upon sec x tan x. I is integral of sec cube x tan x dx. I'm copying the sum as it is. First thing I'm going to do is I'm just going to substitute the value of dx. So sec cube x tan x dx can be written as dt upon sec x tan x. So tan x and tan x gets cancelled. Sec x and cube gets cancelled to give you square. Sec x is t, so this will be integral of t square dt. Integral of t square is t cube upon 3 plus c. Substitute the value sec cube x upon 3 plus c. Simple. Next, let's move on to the next one, guys. Integral of 2e raised to x plus 3e raised to minus x upon 2e raised to x minus 3e raised to minus x the whole raised to 5 dx. Right? Let the denominator be equal to t. So you will get 2e raised to x minus 3e raised to minus x be equal to t. Differentiate with respect to x. 2 as it is. D by dx of e raised to x is e raised to x minus d by dx of e raised to minus x is minus e raised to minus x. So that minus multiplies here to give you plus is dt by dx. Therefore, I can say that dx is equal to dt upon 2e raised to x plus 3e raised to minus x. Let's start with the sum. I is integral of 2e raised to x plus 3e raised to minus x upon denominator can be written as t raised to 5. Dx is nothing but dt upon 2e raised to x plus 3e raised to minus x. So this will be integral of 1 upon t raised to 5 dt. That is integral of t raised to minus 5 dt. This is nothing but t raised to minus 4 upon minus 4 plus c. We substitute the value of t. That is 2e raised to x minus 3e raised to minus x. The whole raised to minus 4 upon minus 4 plus c. Fine. Next, let's see the next one. Integral of x square upon root of 1 minus x raised to 6. Right? You will say let x cube be equal to t. Differentiate with respect to x. Remember, you take that term as t such that when I take derivative of that, I should get the numerator and my numerator should get cancelled. Now d by dx of x cube is 3x square is dt by dx. Therefore dx is equal to dt upon 3x square. I is integral of x square upon square root of 1 minus x raised to 6 can be written as x cube the whole square. Dx can be written as dt upon 3x square. X square gets cancelled. 1 upon 3 integral of 1 upon square root of 1 minus t square dt. Integral of square root of 1 upon integral of 1 upon square root of 1 minus t square is nothing but sine inverse of t plus c. 1 upon 3 sine inverse of t. T can be written as x cube plus c. Next, let's see the next sum. Integral of x squared tan inverse of x cube upon 1 plus x raised to 6 dx. Let us assume that tan inverse of x cube is equal to t. Differentiate with respect to x. If I differentiate with respect to x, I'll get d by dx of tan inverse of x cube is dt by dx. Now this is in the form d by dx of u raised to n. D by dx of u raised to n. Sorry, not u raised to n. D by dx of tan inverse of u. Tan inverse of u is 1 upon 1 plus u square. D by dx of u is dt by dx. So this is 1 upon 1 plus x raised to 6. 3x square is dt by dx. Therefore you can say that dx is 1 plus x raised to 6 upon 3x square dt. Once you have this, then you can start with the sum. I is integral of x square into t upon 1 plus x raised to 6. Dx can be written as 1 plus x raised to 6 3x square dt. X square gone. 1 plus x raised to 6, 1 plus x raised to 6 gone. So this will be 1 upon 3 integral of t dt. 1 upon 3 t square by 2 plus c. Substitute the value of t. Answer will be 1 upon 6 tan inverse of x cube plus c. Right? Next, let's move on to the next sum. Integral of x plus 1 x plus log x the whole square upon 5x dx. Let's see this. You will say let x plus log x be equal to t. Differentiate with respect to x. D by dx of x is 1. D by dx of log x is 1 upon x is dt by dx. So you will get x plus 1 upon x is dt by dx. Therefore you can say that dx is equal to x upon x plus 1 dt. Once you've done this, I can say I is integral of x plus 1 into t square upon 5x. Dx can be written as x upon x plus 1 dt. X and x gets cancelled, x plus 1 gets cancelled. So this is 1 upon 5 integral of t square dt. 1 upon 5 t cube by 3 plus c. T can be written as x plus log x. I'm resubstituting, guys. X plus log x the whole cube upon 15 plus c. Next, let's see the next sum, guys. Integral of e e raised to x 1 plus x upon cos square x e raised to x dx. Right? Let's see the sum. You will say, let us assume that x e raised to x is equal to t. Differentiate with respect to x. Here you will use the uv formula. This is v derivative of u plus u derivative of v is dt by dx. This can be written as e raised to x plus x e raised to x is dt by dx. I would say that dx is equal to dt, take e raised to x common, 1 plus x. Right? Now, let's see this. I can say I is integral of e raised to x 1 plus x upon cos square t. Dx can be written as dt upon e raised to x 1 plus x. E raised to x 1 plus x gone. 1 upon cos is nothing but sec square t dt. Right? Integral of sec square t is nothing but tan t plus c. Resubstitute the value tan x e raised to x plus c. That will be the answer. Next, let's move on to the next one, guys. Integral of e raised to x log of sine of e raised to x upon tan e raised to x dx. Right? Let's see this. You will say let log of sine of e raised to x be equal to t. Differentiate with respect to x. D by dx of log u is 1 upon u. D by dx of u is dt by dx. So this is 1 upon sine e raised to x. D by dx of sine u is cos u. D by dx of u is dt by dx. Right? Now this is going to be cos e raised to x upon sine e raised to x. D by dx of e raised to x is e raised to x is dt by dx. Therefore, I can say dx is sine e raised to x upon cos e raised to x into 1 upon e raised to x dt. But sine upon cos is nothing but tan. So this is tan e raised to x upon e raised to x dt. I can say I is integral of e raised to x t upon tan e raised to x. This can be written as tan e raised to x upon e raised to x dt. E raised to x, e raised to x gets cancelled. Tan e raised to x, tan e raised to x gets cancelled. Integral of t dt, which is nothing but t square by 2 plus c. Substitute the value of t. Log sine e raised to x the whole square by 2 plus c. That will be your answer. Next, let's move on to the next one, guys. Integral of ax raised to n minus 1 upon b x raised to n plus k dx. Right? Let's see this. You will say let b x raised to n plus k be equal to t. Differentiate with respect to x. b as it is. D by dx of x raised to n is nx raised to n minus 1. D by dx of constant is 0, is dt by dx. Therefore, I can say that dx is equal to dt upon bn x raised to n minus 1. I can say I is integral of ax raised to n minus 1 upon t. Dx can be written as dt upon bn x raised to n minus 1. X raised to n minus 1, x raised to n minus 1 gets cancelled. Constants will come out. So this will be a upon bn integral of 1 upon t dt. Right? Integral of 1 upon t is nothing but log mod t plus c. Resubstitute the value of t. So your answer will be a upon bn log mod bx raised to n plus k plus c. Fine. Next, let's move on to the next one, guys. Integral of x raised to e minus 1 plus e raised to x minus 1 upon x raised to e plus e raised to x dx. Right? Let's see this. We'll say let x raised to e plus e raised to x be equal to t. Differentiate with respect to x. dy dx of x raised to n is nx raised to n minus 1 plus dy dx of e raised to x is e raised to x is dt by dx. Now let's observe this very carefully, guys. E x raised to e minus 1 plus e raised to x. I'm dividing by e, I'm multiplying by e. The same term I'm dividing by e, I'm multiplying by e is dt by dx. Now this can be written as, between these two terms I can take e common in the numerator. So this will be x raised to e minus 1 plus law of indices a raised to m upon a raised to n is a raised to m minus n is dt by dx, right? In which case therefore I can say that dx is dt upon e x raised to e minus 1 plus e raised to x minus 1. So you can say I is integral of x raised to e minus 1 plus e raised to x minus 1 upon t. Dx can be written as dt upon e x raised to e minus 1 plus e raised to x minus 1. This and this gets cancelled. So this is going to be 1 upon e integral of 1 upon t dt. 1 upon e integral of 1 upon t is log mod t plus c. 1 upon e log mod x raised to e plus e raised to x plus c. Next, let's see another sum. Integral of cos x minus sin x upon cos x plus sin x dx. Let the denominator be equal to t. So you will get let cos x plus sin x be equal to t. Differentiate with respect to x. So d by dx of cos x is minus sin x. D by dx of sin x is cos x is dt by dx. Therefore, you will get dx is dt upon cos x minus sin x. Rearranging the terms, I is integral of cos x minus sin x upon t. Dx can be written as dt upon cos x minus sin x. So this is integral of 1 upon t dt, which is nothing but log mod t plus c. We substitute the value of t, so log mod, this is going to be nothing but cos x plus sin x plus c. Next, let's see another sum. integral of sec x cosec x upon log of tan x dx. Right? Let's see this. You will say let log of tan x be equal to t, differentiate with respect to x. Dy dx of log u is 1 upon u, dy dx of u is dt by dx. 1 upon tan x. Tan x can be written as sin x upon cos x. Denominator of denominator becomes numerator, into dy dx of tan x is nothing but sec square x is dt by dx. So cos x upon sin x, sec is 1 upon cos is dt by dx. Cos and square gets cancelled. 1 upon sin is nothing but cosec x. 1 upon cos is sec x is dt by dx. Therefore, I can say that dx is dt upon cosec x sec x. I can say I is integral of sec x cosec x upon log of tan x can be written as t, dx can be written as dt upon cosec x sec x. Sec x cancel, cosec x gone. Integral of 1 upon t dt log mod t plus c log mod t. T is nothing but log of tan x plus c. Right? Next, let's see another one. Integral of sin 2x upon a square cos square x plus b square sin square x dx. Let's see this one. Let the denominator be equal to t. So let a square cos square x plus b square sin square x be equal to t. Differentiate with respect to x. A square is as it is. D by dx of u raised to n. N u n minus 1 d by dx of u. Same logic there. B square d by dx of u raised to n. N u n minus 1 d by dx of u is dt by dx. Fine, do we get this? Now this can be written as 2a square cos x. D by dx of cos x is minus sin x. The minus sign I am writing here. Plus 2b square sin x. D by dx of sin x is nothing but cos x is dt by dx. Now in this case I could take 2 sin x cos x common. 2 sin x cos x common, in which case I get minus a square plus b square is dt by dx. But 2 sin x cos x by using multiple angle is nothing but sin 2x into b square minus a square is dt by dx. Therefore, you can say that dx is dt upon b square minus a square into sin 2x. Once you have this, I can say I is integral of sin 2x upon, the denominator can be written as t, dx can be written as dt upon b square minus a square into sin 2x. Sin 2x gone. Constant goes outside the integral, so that's b square minus a square. Integral of 1 upon t dt. Integral of 1 upon t is nothing but log mod t. So b square minus a square log mod t plus c. So this is going to be 1 upon b square minus a square log mod t. T can be written as a square cos square x plus b square sin square x plus c. So that will be your answer. Right? Let's see another sum, guys. Integral of 2e raised to x plus 5 upon e raised to x plus 1 dx. Polynomial type. Degree of polynomial is same in the numerator and denominator. Since the degree of polynomial is same in the numerator and denominator, introduce the denominator in the numerator. Now, in order to get 2e raised to x, I multiply by 2. So I'll get 2e raised to x plus 2, but I want 2e raised to x plus 5, hence I will add 3, split the numerator, 2e raised to x plus 1 upon e raised to x plus 1 dx plus integral of 3 upon e raised to x plus 1 dx. This is 2 integral of dx plus 3 integral of 1 upon e raised to x plus 1 dx. Now, here this can be written as 2 integral of dx is x plus 3. Observe carefully, I'm going to divide by e raised to x, I'm going to divide the numerator and denominator by e raised to x. So I'm dividing the numerator by e raised to x, I'm dividing the denominator by e raised to x. Right? So this can be written as 2x plus 3 integral of e raised to minus x upon 1 plus e raised to minus x dx. This was I. Now you will say let 1 plus e raised to minus x be equal to t. Differentiate with respect to x. So d by dx of e raised to minus x is minus e raised to minus x is dt by dx. So in which case you will get dx is dt upon minus e raised to minus x. I can say I is 2x plus 3 integral of e raised to minus x upon t. Dx can be written as dt upon minus e raised to minus x. E raised to minus x, e raised to minus x gets cancelled. So you will get 2x minus into plus will give you minus 3 integral of 1 upon t dt. 2x minus 3 log mod t plus c. Right? This can be written as t. T can be written as e raised to whatever we assume 1 plus e raised to minus x. So 2x is equal to 2x minus 3 log mod 1 plus e raised to minus x plus c. That will be the answer. Right? Let's move on to the next one, guys. Integral of e raised to 2x plus 1 upon e raised to 2x minus 1 dx. Divide numerator and denominator by e raised to x. So I'll get I is integral of e raised to 2x upon e raised to x plus 1 upon e raised to x. E raised to 2x upon e raised to x minus 1 upon e raised to x dx. This can be written as integral of e raised to x because I'm using law of indices. A raised to m upon a raised to n is a raised to m minus n. 2x minus x, that's how I got the x. Plus, if I take the number in the numerator, the sign of the indice changes. So this will be e raised to x plus e raised to minus x. Same thing in the denominator, e raised to x minus e raised to minus x dx. let e raised to x minus e raised to minus x be equal to t. Differentiate with respect to x. dy dx of e raised to x is e raised to x. dy dx of e raised to minus x is minus e raised to minus x is dt by dx. So you will get dx is dt upon e raised to x plus e raised to minus x. I can say I is integral of e raised to x plus e raised to minus x upon t dt upon e raised to x plus e raised to minus x cancels, integral of 1 upon t dt log mod t plus c log mod t. T can be written as e raised to x minus e raised to minus x plus c. So that will be the answer. Next, last one to finish this chapter. Integral of dx upon root x plus x. I can say I is integral of dx upon root x 1 plus root x. I'm taking root x common, right? Now you will say that let 1 plus root x be equal to t. Differentiate with respect to x. d by dx of 1 is 0. d by dx of root x is nothing but 1 upon 2 root x is dt by dx. Therefore, I'll get dx is 2 root x dt. Once you have this, then I can say that I is integral of dx can be written as 2 root x dt upon root x. 1 plus root x can be written as t. Root x 1, 2 integral of 1 upon t dt 2 log mod t plus c 2 log mod 1 plus root x plus c. We substituted. That will be the answer. This finishes this chapter, substitution, integration. Thank you. Let's stop here for the day.